Good morning, everyone, and welcome to Setting the Stage, the application platform in Windows Server 2016. My name is Andrew Mason, and I'm a principal program manager in the Windows Server and Services org, where I work on the platform and tools team. And joining me today is...
Hi, Taylor Brown. I'm the lead program manager in the Windows division for Windows Server Containers.
So we have a lot to cover today, so we're going to dive right in quickly. And we'll use the first few slides to get through an agenda. You'll see how we'll lay this out in a moment. So there are some key tenets of the development process and some artifacts that you create along the way. So you want to develop, you want to package, you want to configure your app, you want to deploy it, somebody's going to run it. Hopefully along the way there's some testing involved, and then you want to make sure security is integrated into it as part of your app itself and not bolt that on later. And really some of the key things we're going to stress today is about dependencies. You want to minimize your dependencies. And with Windows Server 2016, we have a new installation option called NanoServer, where we're positioning just enough OS. So you can deploy the base OS, and you don't have all the roles and features on top of that unless you absolutely need them. They're separated out, as I'll talk about. So know your dependencies so people can deploy just the pieces they need to run your particular application or service. And know those dependencies, so that as part of that deployment process, you don't have to drag in a lot of stuff, and your IT or operations staff have to guess at what needs to be deployed on that server and deploy a large installation. And so really, along this line, in previous versions of Windows Server, we didn't really have any point of view around these things. There were a variety of ways you could create the artifacts to do those stages of the process. You could create an MSI, you could do Xcopy deployment, you could use WebPI. There's lots of other ways you could deploy your apps and services on Windows Server. There were really no clear choices or recommendations. I mean, if you went down a certain path, there was some guidance to use one method or another. Well, with Windows Server 2016, we're really taking a point of view on those things. There's sort of the traditional operations model, and so there's a set of capabilities within Windows Server itself that lets you create the artifacts along those lines, and then there's the container model that's emerging. And so you can apply some of the same concepts to that, or you can go fully into the container way of doing things. So really with Windows Server 2016, we're resolving that interface between devs and ops, as you'll see on the next couple of slides. So the Windows Server platform basically has solutions or capabilities built into it with Server 2016 that allow you to do all those phases. So for your development, you would target NanoServer. There's an SDK available now for Windows Server that I'll talk more about. Target NanoServer, or an open source app framework running on top of NanoServer. That gives you the smallest footprint for your deployment. Package your apps using WSA. This is a new install technology that we've developed. We'll talk more about that today as well. And for configuration, you can use DSC. For deployment, you can use package management. For running your apps, you can run on a physical machine, in a virtual machine guest, or as a container. And Taylor will talk more about the container aspects of this in a moment. Testing your PowerShell commandlets and scripts and things, you have Pester. Securing your apps, there's just enough administration. So really today what we're going to focus on is NanoServer, the new installer WSA, and containers. There's a bunch of slides in the appendix covering some of the other things and pointing off to resources, but in consideration of time, we really wanted to stress sort of the key pieces. And the important point here is, as you're developing your app, it's not just about doing the development of the app, it's building these artifacts so that when operations gets your app, they know how to deploy, manage, and operate that app. You don't want them doing unnatural acts with your wonderful apps just to get them to run in the environment and making assumptions and guesses and deploying on too large of an infrastructure, beyond what you need. You want to deploy in that minimal environment so that you have the most uptime and the most security available. Now, you can apply these same concepts if you want to sort of use the traditional model for containers, but there's also the container model if you go 100% in with containers.
Yeah, and really the one thing that has been most impressive to me about containers as we've really been working on it is how much it solved kind of this impedance between the developer and the operations team. It's taken away that fight of, hey, that worked on my machine, it doesn't work in production, what's going on, or your server's broken, give me admin rights and I'll take a look at it and fix it and make a whole bunch of changes that you don't know about, or I'll install a different version of something that you don't have the source code for, but I do, and now I've left the company and we can't redeploy the app. All of those kind of challenges kind of melt away when we start looking at containers. Now, a lot of the same principles absolutely apply. So we still want to develop for the smallest OS possible. right? So we have the option to use NanoServer. We have the option to use Server Core. We'll talk a little bit about that. But certainly, where we can, we should be using NanoServer. It's the smallest OS footprint we have. It's going to be the fastest starting. It's got the least attack surface, least amount of patching. Certainly the framework we want to be developing against. Now, when it comes to packaging, containers have a packaging model. It's called a container image, right? So we certainly can take advantage of that. And if that's where our app is going to run, it's going to be in a container, that's absolutely the right thing to do. Now, at the same time, if we want to use a WSA, we can install that into a container image just as well, right? So that gives us a flexibility option for running that application on a physical machine, a virtual machine, or in a container. So either one of those become great options. Now, along with configuration, the container image becomes its own configuration model. So it's the same intent-based principle, but done through the container image model. We'll talk about how that actually works and look at some examples of that as we get a little further in. And then certainly running containers. We've got a variety of orchestration options. We talked about a couple of them in the keynote yesterday with Azure Container Service. So we'll talk a little bit about those at a high level. And then certainly testing, always important. So we always want to continue to do the right thing and test our code. If you want to test in production, that's fine. You know, all the best devs do. But you can also do a lot of great things with unit testing, and containers even make that easier. So as we get further on in this, we'll talk a lot more about some of these specific principles.
Okay. So let's go ahead and talk some about NanoServer. How many people have deployed NanoServer or tried running their apps on NanoServer? All right, there's some hands out there. That's great. Great to see. So let's talk some about what NanoServer is all about. So NanoServer is really, like I mentioned, this concept of just enough OS. It's optimized for your next-gen applications and for your microservices. So it gives you higher density, reduced attack surface, reduced patching, fewer ports open, fewer services running by default, so you have a more secure, minimal environment that you can run your app or service on top of. And it's really designed to run in containers and for your next-gen applications, as I said. It's about 400 megabytes on disk if you don't have any roles or features on it, so it is very small and lightweight. And it is, as we'll see, it is 64-bit only, so you do need 64-bit apps to run on top of it. Now, it provides, we also have Server Core in Windows Server 2016, so that provides sort of your application compatibility for your traditional apps, things that may already exist until they get ported over to NanoServer. And as Taylor mentioned, you can run either of those in a container environment. Then we have sort of the full GUI, the server with a desktop experience for third-party applications that need a GUI that runs locally on the server or for RDSH hosting. Now, NanoServer is the next step in our cloud journey. And so the slide talks about the zero footprint model, but this is really the just enough OS model that I talked about. And what this means is we've removed all the roles and features from the side-by-side folder. So if you deploy just NanoServer and your app or service on top of that, you won't have any roles or features in that image. The roles and features in Server Core and Full Server live in the side-by-side folder. That's why you never have to provide the media when you add something 6 months after you've deployed a machine. And so every time you're deploying an image, you're copying those bits around on your network. You're consuming resources for that OS running on your machine. So NanoServer has separated them out and made them very much like applications, where they're separate packages that you can install on the system. And one of the things we're doing in the next technical preview, back to that use package management point, is we're putting those roles and features up in the same repository where the container-based images are, so you can actually use package management to pull them down and install them when you need them. Now, the roles and features that are available today with Server 2016 are Hyper-V, Scale-Out File Server, Clustering, IIS, and DNS Server. And then we do support .NET Core. That's built into NanoServer. PowerShell Core is built on top of that. And we do support ASP.NET Core. And as you'll see in a few more slides, we also have the capability to run a lot of open source app frameworks on top of NanoServer.
Oh, and don't forget containers.
Oh, containers. Well, that sort of comes under Hyper-V. We do have full driver support, so we have the same driver stack as Windows Server. So if you have a driver that works with Server 2016, it will work with NanoServer. And I'll talk a little bit more about drivers after we talk about installation of code on there. And then we do have Defender. If you've deployed Server Core or Server with a desktop, you'll see Defender's installed by default. Defender is available as an optional package. So if you want to use Defender, you can put that in your image. If you want to use a third-party anti-malware product, you don't have to have Defender anywhere in your image. And then we do have support for System Center, so VMM and Operations Manager agents are both available on it. Now, NanoServer is the cloud application platform. As I said, it's really targeting born-in-the-cloud applications, your next-gen distributed applications. So we do have a subset of Win32. You know, NanoServer being 400 megabytes, it's much smaller than Server Core. As I mentioned, .NET Core and ASP.NET Core. PowerShell desired state configuration is there, so you can use that to do all your configuration. As mentioned earlier, package management or OneGit is fully available there. And so we're using it for some of the inbox components, as I mentioned. And then, as you'll see, the open source app frameworks. And then it can be installed anywhere. So you can run it as your host OS on a physical machine, you can run it as your guest OS in a virtual machine, or you can run it in either of the two container types as your OS for your app. Now, unlike Server Core, where we didn't really have a developer experience, with NanoServer, we learned from the Server Core experience, and we actually have, for the first time, an SDK specifically focused on Windows Server. So let that sink in for a moment. In the past, it's always sort of been the Windows SDK, and all the same concepts applied across Windows and client. Well, with UWP apps, that's very focused on a client experience. With NanoServer, we're very focused on a server experience. We have our own SDK. We have our own documentation around NanoServer, the set of APIs and capabilities available in it. And we actually have integration with Visual Studio. So there is a Visual Studio template you can download and install, and that will allow you to target NanoServer. So you can select NanoServer as the type of app you're going to create, and it gives you the rich design time experience that you expect from Visual Studio. So as you start typing an API, it will give you IntelliSense and show you if the API is available or which version of it's available in NanoServer. If you take your code and load it into Visual Studio in one of those templates, it will give you the little red error squiggles under an API if you're trying to use something that's not available in NanoServer. And then we also have the full remote debugging experience. So we've really done a lot of work to integrate and make it easier to target NanoServer, much easier than what we did with Server Core. The clicker doesn't like me this far away. So as far as application development goes, NanoServer is a deep refactoring. It's the smallest slice of the OS, just enough that you need to run many services and applications. Layered on top of that is Server Core. That gives you more functionality. If you have an application that runs today, you can start by porting to that and then move down to NanoServer. Layered on top of that, we have the client, and we have the remote desktop server and the local admin tools. But really, the client stack's there for RDS. What you want to focus on and the target going forward is NanoServer. Server Core is available for app compat purposes, but NanoServer is really the direction to go, because that will give you the smallest footprint and allow you to target physical, virtual, or container environments. Now, if you have an existing app that you want to port to NanoServer, I'm sure some of you have tried porting some apps onto Server Core. Wasn't a great experience. Again, we have that integration with Visual Studio and the SDK today, unlike with Server Core, where we just had a list of APIs on MSDN. It wasn't very easy to figure out what you were using. Well, we've got some capabilities in NanoServer to make it easier to move your apps over. And so the big one in that environment is reverse forwarders. And so when we did that deep refactoring and made that small subset of Windows Server that we're calling NanoServer, a bunch of APIs can work in that environment, but they are scattered around in the operating system. So there are shell DLLs that have APIs that can access the registry and the file system. Well, we don't want all those shell DLLs in NanoServer. We want to keep it small and focused. So a lot of those APIs move down into other DLLs. Essentially what reverse forwarders give you is if there's a DLL you've linked to that's not available in NanoServer, we have shim versions of those, so those APIs will keep working. So if you're using a high-level API call to access the registry or the file system, there are shims of those available in NanoServer that will redirect you to the new location for that API. So you don't have to relink and recompile your code just to run on NanoServer. Now, this doesn't necessarily eliminate the need to refactor your code, because you still could be using some APIs that aren't available. And going forward, what you'll want to do is, your next version of your app, you'd want to change your link to where those APIs exist within the system. And so The reverse forwarders were an optional package in the previous technical previews, but because we found so many apps benefit from these that we've installed them by default in the base in the next technical preview. So there's no need to install them. And you can see the list of DLLs there that have APIs that are very useful on servers, but those aren't DLLs that we want running in NanoServer. And the benefit of these is we've been able to use these to get a lot of the open source app frameworks running on top of NanoServer. So Node.js, Ruby, Python, Go, some of the other tools and databases, SQLite, MySQL, Java, Redis, all run on top of NanoServer using the reverse forwarder package. So really, as you're moving over to NanoServer, what you want to do is use reverse forwarders to test your app. Try deploying a NanoServer image with the reverse forwarder package installed, or with the next technical preview, just deploy NanoServer and try your app. Then we have two tools available that help you scan your existing code to see if they'll run on NanoServer or what changes you need to make. And so the first one, the NanoServer API scan, that's used for native code. So for Win32 binaries, you can scan it. It will tell you what APIs you may be calling that aren't available in NanoServer, and in many cases suggest a replacement API. And we use this tool internally, both for when we're porting Windows components onto NanoServer, as well as other tools, OOB things that we are making available to work with NanoServer. So these are the same tools the internal NanoServer dev team uses. Then for managed code, you want to refactor to the core CLR, or .NET Core. And they have an API portability analyzer that will help you determine what pieces of the .NET framework you're using that aren't available in NanoServer. So I have a demo here. All right, thank you. So one of these set of tools we've been getting a lot of asks for, both from ops folks as well as developers, because they use it for troubleshooting and debugging, are the sysinternal tools. So we have a team working on porting the sysinternals and making them run on NanoServer. So I've got two of the common ones here, PSExec and PSService, that are used quite frequently. Two of the higher downloaded ones. And so I'm going to use the NanoServer API scan. This is the same process that the team that's porting these went through. So if I run NanoServer API scan against this, the first thing it will do is give me an error because the sysinternal tools are actually 32-bit tools. NanoServer is 64-bit only. So first step was recompile the tools as 64-bit. So here's the pre-ported tools, and you see a whole bunch of APIs scroll past. Just for psservice.exe, you can see it has links in kernel 32, common dialog, and add VAPI 32. And you can see here in a couple places it's saying, instead of computer name, use the EXA version. Instead of enum dependent services, use the W version of the API. So it's telling you what APIs to substitute. So that's helpful. But then if I run it with the reverse forwarders, so I added the reverse forwarder switch here, you see a much shorter link. Basically one API that I have to change in the PSExec service and two APIs in psservice.exe. So much easier to port my code over and make it run with the reverse forwarder package installed. And so you can see that reverse forwarder folder basically just has shim versions of those. It's less than 350K on disk. You can see much smaller than the actual binaries. So like user 32 is 25K versus 139, or 1.3, almost 4 megabytes. So if I run the API scan again, with the recompiled tools, you can see we've made those 3 API changes, and now they run on top of NanoServer. So the reverse forwarders will significantly minimize the amount of porting or code changes you may need to do. So use NanoServer API scan and really scan your code with the reverse forwarders and port using those.
All right. Cool stuff, right? So talk a little bit about what we're doing with containers and containers in NanoServer. So I get started, how many people have used Windows containers in the last year? How many people have given that a try? Yeah, decent show of hands. How many people have used containers in general? Docker containers, Linux? Yeah, that's what I expected. So we're really excited about the progress we've been making over the last year and a lot of the work that we've been doing with Docker and the Docker community. One of the things that we've got that's fairly interesting is we've got a couple different container runtimes. So we'll start with Windows Server containers. So Windows Server containers is very much like the Linux container model. So we've got our Windows kernel, and then on the container host, we've got a set of system processes. So these are kind of the normal system processes you're going to see on every Windows server, right? So things like the session manager and WMI services and the local security authority, all things that just run on Windows Server. And then we have container management. So we've got our compute services, which is kind of our layer of containers in the operating system, and then the Docker engine that's running on that container host. When we actually start up a container, what we're actually doing is we're starting up a new user mode. We're starting up a new instance of user mode, and we actually run another set of those system processes in it. So we've got our own, each container's got their own copy of the session manager, their own copy of the local security authority, their own copy of all of the kind of core system services running inside of it. And then they've got the application process running inside of it. So whatever app you set on the Docker run line, so if it was a web server, it would have its own W3 WP, right? Now the reason that we actually have this model is that without those system processes, you don't really have a real Windows system. You don't have your own, you can't make your own username because that would be shared with the host. So by virtue of having our own copy of those system processes, we have a true container. And it seems like it might be a little heavyweight, right? Like, wow, you're running all these extra processes. Well, doesn't that really slow things down? Not really. So we've done a bunch of optimizations around the way we do memory and startup time, such that we can start a nanoserver container in about 1.15 seconds right now. We're on our way down to a second. That's the goal for Server 2016, right? So that's a pretty amazing startup time. And those system processes really haven't cost us much in terms of memory overhead either, but they give us that right level of isolation. And of course, we can have multiple of these containers running side by side, 10, 20, 50, 100, 1,000, whatever. And each one of them has got their own cognitive system processes. Each one of them really represents their own user mode instance, right? So this is kind of the traditional model of containers, but we weren't satisfied with just being traditional. So we invented a second type of container as well. We call that a Hyper-V container. And so where a Hyper-V container differs, first it starts off with our Hyper-V hypervisor. And again, we've got our container host, and that's got the Windows kernel. It's got its set of system processes, so no difference here. Same set of Docker engine and container management services, so no change here. But when we actually start a Hyper-V container, things are a little different. The Hyper-V container has its own Windows kernel. The Hyper-V container has its own set of basic system processes, actually a much, much smaller set of system processes than what you would normally see. It's basically just enough to start what we call the guest compute service and to start a Windows Server container inside of it, which then has its own real set of system processes and application processes in it. All of this is actually happening inside of a specially purposed virtual machine. We built a special virtual machine that has one purpose in being, to run a container. And we did that so that we get the isolation boundaries that a virtual machine has. It's got the same isolation properties that you get from a VM. If someone figures out some weird way to get outside of that container and mess with the kernel, great, they can crash themselves. They can't do anything else. There's no harm that they can do to anybody else. It also means that we've got kernel independence. We can run different versions of the kernel in the container. So we could run it on different versions of the operating system, all sorts of interesting things that we'll get into, right? And by virtue of the fact that we're actually just running a Windows Server container inside of this optimized virtual machine, they're the exact same container image format and the exact same management API. It's literally a one flag difference to Docker to choose between a Hyper-V container and a Windows Server container. So that gives us a lot of flexibility. When we go into production, if we decide, you know what, we're running on some public cloud and we've got a bunch of different containers running side by side, we really want that extra isolation. We want that known boundary of a VM. Cool. We flip the switch. We run it as a Hyper-V container. If we're running in our own environment, we're running on our desktop, we're running in pre-production, we're doing testing, we can run it as a Windows Server container. No change. It's the exact same container image across both. So a couple notes on the deployment model. So with Windows Server containers, at least for now, the container has to match the container host. So If I'm running a Nano container, it's got to be running on a Nano container host. If I'm running a server core container, it runs on a server core host. This will be relaxed in the future. We're working on relaxing some of those requirements for Server 2016 GA. But for the current technical preview and for the next technical preview, that's certainly going to be the case. With Hyper-V containers, the container has to be Nano server. That's true today. That'll be true in the next preview. We do have server core support coming for GA, so you'll be able to run a server core Hyper-V container. But for now, it is Nano server only. The host itself can be anything we want, right? Because we've got our own kernel, we've got our own independent version, so we can run that on Nano server, we could run it on Windows Server Core, we could run it on server with a desktop. Couple things about where you can run containers. So we can run them in Azure. So we've got an Azure image, so you go to the Azure Marketplace, you can deploy the Windows Server 2016 Technical Preview 4 image, and you can spin up Windows Server containers there. Fantastic. Hyper-V containers is going to come to that as well. We've got nesting support coming into Azure, so that we'll be able to run Hyper-V containers in Azure as well in the not too distant future. We can certainly run them on an existing server or a physical or a VM. So you've got a server, you install Server 2016 Technical Preview 4 on it, enable the Hyper-V role and the containers role, and you can run Windows Server containers or Hyper-V containers on that. And then, of course, with nested virtualization, we can spin up a VM either on a Windows 10 host or a Windows Server 2016 host and run containers inside of that, right? So 3 different places and ways we can run containers. And all of these are on our Quick Start documentation page. We've got links throughout this deck to where that is. But today, we get to announce something new. We're bringing Hyper-V containers to Windows 10 natively. And so let's take a look at what that looks like. All right, so this is my demo laptop running Windows 10. I'm an insider, so I've got the Windows Insider build installed on it. And I'm just going to open up my Docker window here. So all I have to do to start a container on this sucker now is just say docker run, and I'm going to say I want an interactive session for it. I'm going to say Nano server and CMD. I'm just going to run with a command prompt. And there we go. This is starting up that optimized VM in the background and starting up Nano server inside of it. And here we go. We are in a Nano server container running natively on my Hyper-V as a Hyper-V container natively on Windows 10. So I can look around in this guy. I can do an IP config, all the things I would normally expect to be able to do on a server. I can open PowerShell. So PowerShell takes a second to start up. So we have to engine all the binaries. So now we're in PowerShell. So I can actually run a command there. That's proof. Our server level says that we are a Nano server. So we are in a Nano server container running on this Windows 10 host.
That's cool.
So what this really does for us is this makes building your applications on Nano servers super easy, right? You've got your development environment that you're familiar with. You've got all of the tools that you're used to, but you can spin up a Nano server container in a couple seconds, do all of your development. If you make a mistake, that was easy. I just exited out. The container goes away. All the changes that were captured out of it just get thrown away. No harm, no foul, right? It's that easy. Now I could go back, recompile my binary, push it back in, try it again. Once I've got it ready to go, I'm done. Makes developing on Nano server super, super easy for us. So a couple comments on this. So the platform support is actually in Windows Insider builds, some of them today. So if you've got the Enterprise Edition, you could actually see the role there. It'll be added to Pro and EDU in the next flight. Again, Nano server only, but server core support is coming. So we will have server core containers as part of this as well, as soon as those are available. Now, the Docker engine and the container OS image, the Nano server image, is coming as part of Technical Preview 5, which is going to be released fairly soon here. So we've got to wait for that to really get started with this, but just hold your patience. It'll be just a little while. And if you follow me on Twitter or you keep an eye on AKAMS/containers, as soon as that all drops, we'll have quick start guides there to get you all started with it. Make your development super, super simple. So.
All right, cool stuff. So let's talk some about how you can package apps using Windows Server App Installer. So MSI is not supported on NanoServer. MSI has a bunch of dependencies. It requires some GUI. It allows you to run custom actions that can do anything in the system. So for reliability purposes, those changes could call things that wouldn't be available in NanoServer, so it'd be very difficult to know, is an MSI that I have for a particular app going to run on NanoServer or not? This caused a bunch of pain with Server Core, where we did support MSI, but there was never an easy way without trying an MSI to see if it would actually work on Server Core. So we've changed that model with NanoServer, and we've decided that MSI is not the route to go. On the client side, everything's moving towards AppX. And so the Windows Server App Installer is based on AppX. Now, some of you familiar with AppX on the client side are probably wondering, well, this AppX constrains me. I have to run in a sandbox. There are limited capabilities an AppX app has to the system. What does that mean for trying to install something on Windows Server? And so we've created a bunch of extensions that allow Windows Server or server-type apps and services and things to install using AppX. So when you're deploying a WSA app, it's actually breaking through the sandbox. You're not constrained on Windows Server like you are with an AppX package on a Windows client machine. And we have a bunch of extensions that I'll talk about that allow you to deploy things like services that have full access to the system. Now, how many people went to any Centennial sessions this week? Okay, I see some hands. And so you're probably wondering, okay, what's the difference between AppX and Centennial and WSA? Well, Centennial and WSA have some overlap and consistency. So our goal is at Server 2016 RTM, a Centennial app that installs on client will also install through WSA on NanoServer. So if you need to run on both platforms, you can package up as a Centennial app. If you need some of the advanced capabilities of WSA to run a server app and have full services and everything, then you would need to create a WSA package for that. So you see, you can do some of the same things. Some of the extension handlers are consistent between Centennial and WSA, where there is overlap. And so this will not be specific to NanoServer. This is the new installer for server apps all up. So this will be available on Server Core and Server with a desktop as well. So this allows you to create a single installer that you can use across any of the Windows Server installation options. Now, essentially, it's very much like creating a AppX package. As you'll see from the demo, the schema is the same. We just have some extensions there. It looks very much like AppX until you get into some of those extensions. So essentially, you describe your package in a manifest. Now, in Windows Server 2016, we will only be supporting online install of WSA packages. We are working towards supporting offline install, but that's not going to make RTM at this point, but it is on our roadmap, and we will be making that available. Now, one of the big differences between WSA and an MSI is there is no custom code allowed or custom actions. You need to describe what you're installing on the system, and then either as part of your configuration settings that you apply through DSC or through your first startup is then when you do further configuration to the system. And so it is a declarative installer, lets you do file and registry just like AppX, and then we have a bunch of server extensions. I mentioned services, but we also have COM object support, WMI provider support, performance counter and E2W support is coming in the next technical preview. So if you download TP4 and start playing with this, that's not fully available yet, but it will be there in the next technical preview. Now, when to choose WSA versus an MSI or some other install technology? So if you need to support installation on NanoServer, WSA is the route to go. If your installation involves system and OS level changes, WSA provides that capability. It's not constraining you like a AppX package would. If you need to support uninstall and servicing, so those will both be supported with WSA. And if you need to declare dependencies, so we will add the capability to declare dependencies on inbox components to WSA. So if you have an app that requires IIS, for example, you could declare a dependency on that, and if that's not installed on the machine, that would get installed as part of your install process. You don't have to tell your ops folks to go through a two-step process. You can deploy all the dependencies you need. Now, WSA does not support any GUI, does not take interactive input, so it is very much like an Apex package on a client machine. It deploys the files, registries, and any of the things you've described in the extensions, but does not give you any interactive environment. So if you do need that, you will have to stick with an MSI or use some other deployment methodology. It also doesn't allow you to run custom code. So we're still working on WSA, as you can see from some of the pieces we're adding in the future post-RTM. So if you have feedback on capabilities and things you need in WSA, please share that with us. We want to keep evolving this and making sure it meets the needs for all the server apps out there. Now, packaging is pretty straightforward. You author a manifest file, just like you would with an Apex. Then you use makeapex.exe, same tool that you would use to create any other Apex package, creates a WSA package, and then you have to sign it. And that's the extent of what you need to do. So it's the same workflow you would follow for creating any other Apex package. As far as installation goes, we have the same Apex commandlets are included in NanoServer, so you can use those Apex commandlets to deploy your WSA package. So the command line steps are exactly the same for deployment, or you can use package management to pull your package down from a remote source and use install package to apply it. So let me flip over and show a little bit about WSA here.
Trying to go to my machine.
Yes,
I'm just
probably wouldn't work.
excited.
You're excited to go on with containers. Awesome. So I have a NanoServer image running in a virtual machine on here. And so I'm going to go ahead and use PowerShell remoting to connect into it. And again, as Taylor showed, I'll query that registry key. So this registry key has existed since Windows Server 2012 and was available to tell you could use this to query whether you're running on server core, the minimal server interface, or server with the desktop experience. And so we've extended this and added a NanoServer level in there. So if you go look at the MSDN documentation for this, you'll see NanoServer is already listed in there. So this registry key has been around for a while and is way through scripts or code that you can see what you're running on. So let me switch over to my demo folder. Now if I run git apex, you'll see it returns nothing because I don't have anything installed. If I look at my Windows apps folders, there's nothing there, but I have a sample WSA app that I'll install. And now when I run git apex package, you can see it's showing me my test sample installed from the common Contoso company that's used in all our demos. But you can see I'm using the same apex commandlets that I would use on a client machine to install a package. And now if I look at my Windows apps folder, you can see I have my package registered in there and the directories there. And you can see I have my app manifest in there. I have a couple of services. I have an event provider. I have MOF files for WMI. So I've installed a bunch of things in there. And if I run git service, you can see I now have 2 new services on my system. Service name and a dependent service name. So if I switch over to actually have the Apex manifest here loaded in Visual Studio. If I take a look, the top part looks pretty similar to any other Apex manifest. The difference is right now we have this server preview package at the beginning here, and our target device family is Windows Server. Other than that, it looks like any other Apex at this point. And then I install my test app, the various properties I have. Then under applications, I specify my ID and my visual elements. But then down here, we have this extension section. And that's where we start to see the extensions that are specific to server. So here we have an NT services extension. And here's my dependent service exec.exe with a bunch of parameters defined. This is just a test package. It doesn't really do a whole lot. But then you can see my second service exec.exe. And down here, I've defined my service dependency on that other service. So you can do all the standard service type registrations that you would, through an MSI or through other means through a WSA with this extension handler. Then going down some, you can see I have my WMI provider extension. Here I am installing my MOF providers. I have my COM extensions for my COM registrations, app ID, so I can set permissions on it. Then I have my in-process server extension, so I can register my instance provider, performance providers, all the capabilities. Oops, you might need to deploy a server app or service on top of Windows servers available through WSA with these extensions that we've created for AppX. And then I just want to flip back over here. And the nice thing is you can quickly remove these. See how fast that went? It wasn't a lot of files. But if I go back and I run get service now, those services are completely gone and unregistered from the system. So I've cleaned it up. It's much faster than going through an MSI and clicking next through a bunch of dialog boxes. So we can switch back to the slides. All right, so we have a bunch of resources available already around WSA on the NanoServer blog. We'll be moving this as well as more content into MSDN so that you can start building your WSA apps or packages. We have a nanoserver at Microsoft.com alias if you have questions about this. And in addition to providing this through all the AppX tools built into the Windows SDK, we've also been working with FireGiant and Flexera. So FireGiant is the commercial provider for Wix. They have already released an extension that you can use. So if you're using Wix to create your MSIs, with their extension, you can output both an MSI and a WSA package. Flexera is working on a similar solution for Install Shield. So we've been working with the ecosystem to make it easy if you've, many of you already have MSIs, make it easy for you to transition over to a WSA. I mentioned earlier I wanted to speak briefly about drivers. So drivers will not be supported via WSA in Windows Server 2016. Driver installation remains INF based. So for plug-and-play hardware drivers, or actually any driver with an INF, we have a script that you can use to build your NanoServer image. One of the parameters you can pass to that is a drivers flag with a path where your drivers are. And so it will load, inject in the image all the drivers in that particular path. So it's very easy to put your drivers into your image. Now, hardware plug-and-play drivers, we do have offline support, as I mentioned, using DISM or using that script that builds your image. And online support is coming. It's not going to be there in TP5, but you'll see in future builds that PNP util is coming to NanoServer so that you can use that to install drivers online. For filter system drivers, you do have to potentially modify your INF syntax. So there's some differences between different types of filter drivers, between network and file system filter drivers. We're working with the driver team to unify that syntax and make it possible to install those offline initially in NanoServer, and then we will be adding online install after that. So there'll be more documentation coming on that, but that's the story with drivers. Right.
All right. Ready for some more containers? Yeah. All right. So let's talk a little bit about how we actually go about building container-based applications. So the first important thing to kind of level set is what is a container image. So the container image is really what it's really a template for all containers. So in the world of Docker, all containers started from a container image. There was first a base image, and then containers came from that base image. The container image is a read-only template. It's file-based, so it has all of the files that are necessary to run that container, all of the user mode binaries, all of the application binaries, all of those things are contained within the image. As well as some metadata. And so this is actually kind of, if you cracked open a Docker container image, this is what you'd ultimately see inside of it. There's an image metadata that's a JSON file, so that has things like the name of the image, its SHA hash, the history of the image, who maintained it, who created it, all of that kind of information. And then a set of layers. And these layers are really kind of the magic. The layers are, have their own little piece of JSON in them, their own little manifest. And then they've actually got the image payload in it. And each image has one or more layers inside of it. And the reason that these layers exist is that when we actually go through something like a Docker build, which we'll talk about in a minute, the layers allow us to do some caching things. So if we didn't make a change to one particular section of that file, we don't rerun it. Each line of a Docker file is its own layer. And that gives us some really, really amazing flexibility. The way that we actually create a container image, there's three basically approaches. There's a manual approach. So if you wanted to, you can interact with the container. You can, just like I did when I said Docker run NanoServer, I can go in there and I can install an application from the command line. I can make file changes. I can do all of the normal things I would do interactively. And then when I'm done, I can just say Docker commit. So that would be a manual approach to making a container image. But that's not very DevOpsy, not very efficient overall. So the more efficient way to do that would be with a Docker file. And that's really an automated way to produce a container image. So you're all developers, you know what a makefile is, right? Dockerfile is a makefile for containers. And we'll talk about exactly what it looks like in a moment here. And then the last way is I could actually pull the container image from a registry. So I could pull it from like the Docker Hub. So if I said Docker pull Redis, that would pull down the Redis image from the Docker Hub. So let's dive into a Docker file for a minute, because that's really the preferred way to be making a container image if you can't pull it from the registry. So again, it's a method for automated container image creation. It's consumed when we say Docker build. So we say Docker build, it reads the Docker file. That's what the Docker engine does. It can also be used as part of automation. So you can upload your Docker file to the Docker Hub. And what that does, or one of the advantages to that, is that it can be an automated triggered build. So if an image that you're dependent on changes, they will automatically rebuild your image. Pretty handy. Now, you can also get a webhook for that build happening, which then would allow you to like kick off some CI testing or kick off a redeployment of your image. So you can do all sorts of additional automation that way. So that's another big benefit. Oops. And as I mentioned a minute ago, anything that's unchanged just gets cached. So if we take an example, so this is an example of a Docker file to build an IIS image. So we start off with the from command. The from command says this is where we're starting. So we're starting from NanoServer. And then we've got two adds. The first add adds an unattended XML file. So this is actually how you install the IIS role in NanoServer on Technical Preview 4. So you make an unattend file. So I'm adding that unattend file to the container image. And then I'm adding the packages directory, as Andrew talked about earlier. Right? So I'm adding those packages over to the NanoServer image. And then in the container, I'm running DISM. So DISM is what we use to install packages. So I'm just saying DISM online, apply this unattend file. Right? Those are basically the 4 steps to building an IIS image. Now, when I say unchanged commands are cached, let's say I realized, you know what, I made a mistake. That unattend file, it needed to be in a different directory, so I changed the last line of that file. Docker's smart enough to go, well, the only thing that changed is the last line. I will use the layers from before. I'll just throw away that last layer and just run that last command. It doesn't add the unattend file. It doesn't have to add the packages. It's already done that before, and it knows that. So pretty smart. Now, if I want to build a subsequent thing, because I actually want to have a website, then I can say from IIS. So I'm now saying I'm going to start from the previous image I just had a moment ago, and I'm just going to add in mysite.htm, and I'm going to put it in inetpub mysite.html. Right? So that would just copy that file in, and now I've made a web image. Right? And just kind of like on the image on the far left side there, or I guess your guys' right side, the way this ends up looking is the MySite image depends on the IIS image, which depends on the container image. Right? There's a hard dependency between all of those. Now, if I want to share this all with Andrew, he's already got the container OS image, because he's already been playing with containers. All I have to do is ship him the IIS image and the website image. If he already had the IIS image, I just ship him the web image. Right? So I just give him just enough of the images for him to get started. So very, very handy for sharing work. Now let's talk a little bit about composition and orchestration, because really what's interesting is applications that have multiple pieces. So in the world of Docker, the way that they think about this is through 2 tools, Compose and Swarm. We'll focus most of our time on Compose, because what Compose allows us to do is to define a multi-container application. So in the little example that's very hard to read and very small over there, I've got a 2-tier application. It's got a website and a database. So what my Compose file has in it is the information about the website and the information about the database. And we'll dive into a demo, and I'll show this in detail in a minute. But this allows me to build a container application that's comprised of both of those things. And then I issue a single command to operate against that entire application. So I say Docker compose up, and it will start up the database image and the web image. Right? So I'm actually operating against my application now, not the individual containers themselves. I can scale independent tiers, so I could then say scale the web tier to 3, and it will scale up to 3 web images. Right? What Swarm does is Swarm aggregates a set of container hosts. So if I've got 10 hosts, 10 different VMs, across 2 different data centers, whatever. Swarm makes those look like one single Docker host. Right? So I can operate against that whole set of container hosts as if it was one thing. And it has all sorts of information about tagging, so you can do tags for locations and all sorts of anti-affinity type things. The other one we talk about a lot is Mesos or Mesosphere and Marathon. So this is another great orchestration technology. This is what we're using in the container service as well as Swarm. So this aggregates container hosts, great web-based UI, really excels at some of the service discovery, service launch and discovery capabilities. And utilizes the Docker command line, so it's fully compatible with the Docker images as well. So either of these are great options. We have both of them as part of the container service. And Swarm will be, we will have an alpha available of Swarm for Windows with Technical Preview 5. So that's going to be coming very soon as well. Nothing quite like a demo to really land this stuff. So let's kick over and take a look at this in action. All right, so we're back to my machine here. And I'm in a PowerShell or a command window, and I'm actually using this is a VM running on this machine, so I'm just remotely connected to it. So if I do Docker info, you can see all the information about it. So I'm running Server 2016, I'm running a Technical Preview 5 build, so this is very similar to what you all are gonna have in your hands fairly soon here. And I'm in a directory that I've called compose node.js. So if I do a directory list in here, we can see some information about it. But let's just open Visual Studio Code. All right. So the magic of Compose is all about this compose file. So we'll zoom in, make it real easy to see. So again, the compose file is what describes the multi-container application. So in this particular one, we've got 2 tiers. We've got a web tier, and we've got a database tier. So the web tier has some directions. To build it, go into the web directory, and there's a Docker file there. And sure enough, if we look in the web directory, there's a Docker file. All that Docker file does is say, from Windows Server Core, add in node, so I'm adding in node.exe, and add in web.js, which is my little website written in Node. And then I'm setting the command to be run node SQL web.js. Pretty simple, right? So back to our compose file. I'm saying it's using the default networking, and I'm giving it a link. So I'm saying this web image depends on the database, right? It's going to use the database to do some stuff. And it exposes port 80, right? And that'll be important in a minute here. And then for the database, I'm just saying build is in the database directory, so there's a Docker file there to build my SQL image, and the net is default as well. Now, as we said earlier, all we have to do to operate on this is say Docker compose. So if I want to build my entire application, I say Docker compose build. Now that reads that Docker file, or that compose file, and goes off and builds both the web and the database container image in one command. Pretty handy. If that had failed, it would fail all the way through. Now to start it, all I have to do is say Docker compose up, and I'm going to say -d because I want these to start in daemon mode. And it's creating the database first because that's the dependent thing. And now it's creating the web container. And so now I can say Docker compose PS to list the containers. And sure enough, we've got our database container and we've got our web container. And that's published on port 48991, right? Because remember we said it needed port 80? Well, it picked a random port to publish port 82 on my container host. So let's see what that website has on it. There we go. That is my extent of Node programming. Now, we talked about scale earlier, and scale's kind of cool. So, I'm going to make sure my app actually scales the way it's supposed to, right? So I don't have some weird thing where it doesn't, if I'm running 2 instances of the web server, something weird happens. So all I have to do is say Docker compose scale web equals, let's try 3. So now I'm starting up 2 more web servers. So if I do Docker compose PS, we now see we've got our original one and we've got 2 new ones. Well, let's pick this last guy, and we'll go to his version of the site too. Boom. Then we got another one. And we can see that they are different. We get different IP addresses. These are actually just NATed IP addresses, so they're both local to that container host, but they're published on different ports, right? So now I can actually test to make sure my application works both at scale on my laptop, or I can push it out into production and have it scale the same way with Swarm, right? So pretty neat. Now, if I want to take it down, all I have to do is say docker compose down, and it would take down all of those containers. But I like having my stuff up, so we'll just say up, right? That's simple for creating multi-container applications. But we're not done yet. We've got one more pretty cool announcement. We're doing PowerShell for Docker. You know, we've got this model where we've got the operating system, we've got the Docker engine on top of it, and today we've got a couple different things that talk to the Docker engine. The client, we've got Compose that we just showed, registry, and we've got Swarm. What we're going to introduce into this now is PowerShell. So PowerShell, this new PowerShell module will call directly into the Docker engine. It'll use the Docker REST APIs to do that communication. We're going to be open sourcing it. It'll be open source probably next week. And it's going to replace the existing container module that we have in Box, right? So no more do we have to choose between PowerShell, which I know I love, right? My career has been built around PowerShell. My first session was PDC, talking about PowerShell and VMs, years ago. Kind of dating myself. So you don't have to choose anymore between PowerShell and Docker. You get the best of both worlds. And because it's talking to the Docker REST interface, it'll work against Linux too. So you can now manage your Linux containers from Windows remotely using PowerShell, just the same way you would with Windows containers. Now, as we're doing this, we're going to need your help. Why? We don't exactly know what this module should look like. I'm going to show you a demo in just a second. We've taken some guesses, but we're very sure that people are going to want slightly different things, different parameter sets, different command line syntax, different output. So we really want to make this a community-driven affair. We want the PowerShell community, we want the Docker community to come together and help us build this module in the way that makes the most sense for all of you, right? And just because it's fun to show, let's go ahead and show it. So we've got a PowerShell window here. You can see this is going to show it's just in its infancy. Now we've got Git container. There's that web container. There's the database container. We can see it's got a port. We can do Git container image. That's going to show us the container images. There's the SHA hashes and everything, all talking to that remote container host that I had, right? So this is our new PowerShell module in the early version of it anyway, that we'll be open sourcing probably early next week, certainly at the latest the week after. So this is going to be a great, I think, addition to the Docker family and the Docker arsenal that we've got coming together. All right. So with that, I think we're ready to.
Mm-hmm. So as you've seen from all the different things we've shown today, we're really trying to resolve the interface between devs and ops with all the capabilities we're building into Windows Server 2016. So we made a bunch of improvements here. Just to sort of summarize and talk about a few things that we need your help with, as Taylor mentioned. You know, we've got a lot of new pieces, Nano Server, the Windows Server app installer, you know, package management. We're expanding how that's going to be used. So really what we need to do is start targeting Nano Server, start running your apps, start porting your apps to Nano Server, give us feedback on that, create your WSAs and give us feedback on capabilities or functionality that might be missing in that. You know, we have nanoserver at Microsoft.com, comes straight into my inbox as well as some of the rest of the team. And we have a user voice site for Windows Server as well, where there's a nanoserver section. So try these things out, give us feedback. We're still making changes. We're still adding APIs in the reverse forwarders. So the sooner you try your things and give us that feedback, the better chance we have to make those changes in time to get them into Server 2016.
Yep. And also with containers. So you can learn more about containers, aka.ms/containers. Give it a try. That documentation portal is all backed by GitHub anyway, so if you don't like the way the documentation works, you find a bug in it, you think you can make it better, submit a PR, we accept them very quickly. We're quickly growing a community around that, which we're really excited about. Give your apps a try on Windows containers. So we just made it super easy to try containers in Windows 10. Give it a try. Let us know what works. Let us know what doesn't work. Along with what Andrew was saying, we're actively looking at the forums all the time. Your guys' feedback is really what determines what we do with things, right? You gave us the feedback that we needed to do something different with PowerShell. That's what we did, right? It was because of the feedback we got from our users that we were able to make that change. Get ready for Technical Preview 5. It's coming soon. And please continue to give us feedback, bug reports. There's lots of different ways you can submit them. GitHub, forums. You can send me an email or send me a tweet. I'm happy to get those all the time as well.
And we went right up to the end of the time, and we'll take questions until they kick us out. But down in the hub area downstairs, if you go in and off to the right in the Azure area, we do have a stand there where you can come ask further questions if we don't get to your question now. Thank you all very much.